All right, you guys. So the phase right after the pending callbacks is what is called the idle prepare phase. It's a two-in-one phase, and it's really we can call it an invisible phase. It's not something that us users really care about. It's there for Node to do some internal works, especially the idle part. Like when the loop is idle, when there is no user code, Node can take this opportunity to execute its own stuff when it's idle. Does that make sense? It's just because we cannot just run random code at random times. You need to be consistent at some point when it comes to a loop that needs to be predictable, right? So this where the idle code runs Node internal code, and there is a specific also stage in that is called the prepare, where we're preparing for the next phase, which is the most important phase right after this lecture, which is called the pull phase. See? And mainly the preparing is we're preparing to do an IO. You see, when you do an IO, like reading from file, reading from socket or connection, there is some setup that needs to happen because you need to do certain data structures to actually perform the IO. Like an example for this is EPOL for Linux, KQ for Mac, BSD stuff, and IOCP for Windows, and IOU ring recent Linux kernel upgrades. So yeah, you need to set things up, and let's talk about this stuff. So you need to set these data structures in order to perform the IO. And at the end of the lecture, what we're gonna do is there is not much we can do here to show how the idle prepare works, but I can definitely show the prepare part, what Node does to prepare for an IO. That I can show you in the code, right? By doing an strace and see the system calls that Node executes. And at that part, we're gonna show you that. So I'm not gonna leave you dry there. All right, so the initial phase, talked about that. That's the start of the code before the event loop. Timers, this is where timer callbacks are executed when the time elapses. Pending callbacks, these are where TCP errors at the end of the things. This is where things execute. Idle prepare, that's where we are now. It's an internal phase, but I'm adding it here for completion. So yeah, it's two steps and really used by this underlying library that's called libuv. That's where the actual code executes, and Node just maps this phase to this libuv library in order to just, for completion reason. It's important to understand that this loop that we talked about is actually not Node's, but actually libuv's, which is the underlying library that Node uses for the IO. Okay, so this all this loop, all this stuff is actually libuv. This is the library underneath Node, right? And then Node just maps the phases one-to-one to this libuv, and we're gonna talk about that in common lectures. Okay, and yeah, you can of course in this phase, it's not really exposed to us. Like we cannot measure it or feel it. It's completely internal to Node. It's doing some works at the back end, right? That is invisible to us as users. But if you really want to hook into this phase, let's see, into the idle, this can be overridden using C++ add-ons. The last section, we're gonna show how to write a C++ add-on using Node. All right, the idle stage of this phase. And it's basically Node executes internal tasks in every single iteration, right? And it's called idle. It's a weird name. It doesn't execute when things go idle, but it actually just executes in every single iteration and runs some internal task. I just added it for completion reasons here. But yeah, this actually runs in every iteration, and Node runs its own internal task in this stage. But this is what I'm interested in more, because this is actually something we can feel and see in the system calls, right? So this is the preparation, right? You see, every single IO that we perform need to be prepared. We need to set it up. A perfect example is when you have a server that is listening, like a web server. Like you built a web server using Express or raw HTTP server. When you receive a connection from a client and you accept it, what happens is you need to read from this connection. And to read, you need to use at least one asynchronous IO method is called epoll, which I talked about in my operating system course, and I'm gonna borrow that lecture and add it here and when the time comes. So don't worry about it. We're gonna go through it in details there. So epoll essentially is the method by which we can poll for IO on this connection. So let's say I just receive a new connection. You're gonna add it. You're gonna use a epoll control to add this connection. So 10 is in this case the file descriptor for the connection, and you're gonna add it to this particular control, right? To this particular epoll, and then it's gonna start listening on these connection events. So if there is a read, it will start reading from the connection, right? And as you get more data, you gotta read it from, right? You read from this file from the connection. And the other setup operation is you want to delete from the epoll. Like let's say the connection has been closed, there's no longer the need to actually listen or do anything to this connection, right? So you have to remove it from the epoll data structure. And that's basically one example of things that happen in the prepare stage. So how about we go and show this? So what I'm gonna do here is I'm gonna use Ubuntu, my Ubuntu box, to run essentially the same code on Node. And the reason I use Ubuntu is because I need a Linux machine for this. You know, here's the thing. You can do this in Mac, you can do this in Windows, but by far the best system call capture tool is Strace. This beautiful tool that's called Strace. I couldn't find anything like that in Mac. So I'm using that to actually, break the black box that is Node.js and see what Node.js sends. Yeah, it's like if you're in Chrome and you go to DevTools and you see the network calls that your page makes. This is exactly what Strace does. It just shows you all the system calls that your app makes to the kernel. And that's very critical to see how your app behaving. So what I'm going to do here, essentially, I'm going to first disappear so you can see the full screen. And let's find that. So here, I'm going to go to Node. Yeah. This is going to be Vim. I'm going to show you the code. I think it's the idle prepare is 4. Right, let's go ahead and do that. And I think it's just one thing here. So let's go through that. Vim, I'm just gonna Vim through that and show you this code here. Okay, so here's the code that we're gonna execute. Right? But before we do that, I'm requiring the net package here. I'm creating a server, a TCP server, and I'm just waiting on listening on data that comes from the server. And we're also listening on the end event, which is not really critical here, but this is the most important thing. We're listening on port 3000. I'm listening on all IP addresses on all interfaces. That Ubuntu machine is hooked to an Ethernet, so I want to make sure that, but sometimes I hook it to the Ethernet, sometimes I hook it to the Wi-Fi, so I want to listen on both just in case. So I use 000 to listen on both, on all interfaces. So we're listening to that 3000, right? And that's it. And after 30 seconds, I close the server. That's what it does, right? So it's a simple thing. But so what I'm going to do is I'm going to go ahead and run this tool, but what I'm going to do is run it using Strace. So here's how you do it. You do Strace I have this in the useful commands. So we're going to run this tool, but we're going to preface it with strace before that. So you do strace, right? And if you have any Linux machine, strace will be installed for you. And you do -f, means we need, -f is very critical because Node is a multi-threaded application. I know I said single-threaded. Yes, it's a single-threaded when it comes to Node itself, but libuv, which is the library that we reference, is multi-threaded. There's like a bunch of threads that does all these work. They do all this work. So we need to do -f to follow every single thread, not just the main process. We need to capture pretty much anything made by any thread that is spun up from this main process that I'm going to execute. Do -t. We do -t so we can add timestamps because we need to see the timestamps, of course. And then -o, the output, and let's call it prepare.txt, right? That's the output. And then you run the program, which is Node. And of course, we are in the root, so we need to run node 04, node 040. And then we say run. And quickly before we close, I'm going to spin up a command window and I do telnet 192.168.7.179 on port 3000. And I connect it. And I send something. And I'm going to close. So before I close this, I'm going to open a bunch of tabs and I'm going to prepare a connection right here. 179 is the IP address. I'm preparing a telnet to connect to the same server that I'm about to connect to, right? But I'm gonna prepare just a bunch of them here, right? Telnet 192.168.7.179.3000. So let's go ahead and start, and then connect here, and then connect here, and then I'm gonna close the connection here, right? And then we quit. I think that's how you quit. Yeah, I close the connection. And then send something perhaps, and then close, and then quit. Good. And then we wait. We come back here and wait for the 30 seconds to elapse. And then eventually you'll see that the program after 30 seconds is gonna close by itself. There you go. The program closed. Now if I go vim prepare.txt, you'll see this beautiful juicy sets of system calls, you guys. And that's my favorite part of the things, right? So now what I'm gonna do is look for epoll. What we want to look up, essentially, I want you to pay attention to these controls here, right? Epoll control. And let's go up a little bit. I want to go from the beginning. And there is a lot going on here, but what I'm interested in, let's start with a socket, right? Here's the first thing. This is our listening socket. And we created a socket and we got back the file descriptor for that socket, and it's 20. That means, hey, I created a socket listener. That's just this listening socket. Now I'm gonna go ahead and set the properties. Then I'm gonna bind it to port 3000. That is the interesting part here. Then I'm gonna listen, and by doing listening, calling that listen, now we're ready to receive connections, right? So what I'm interested in next is, once we did that, right? Let's forget about 14 and 16 here, because there is a lot of other stuff going on. But this is what we're interested in here. We added that socket listener as part of the epoll to actually start receiving connections on this, right? And you need to do epoll control. That's done in the prepare stage. And then what we're doing is we say, hey, epoll in, give me any input that comes to that. And what we're interested here in is connections that coming to that socket 20, right? So this is just the socket that is receiving connections. Sweet. Now the next thing is this. We received a connection and immediately we got back that, hey, epoll told us that, hey, we waited, and epoll told us that, hey, You got something on 20, which is 20 is the socket listener, right? If we got something, what do? Immediately, we call accept on it, accept for. And accepting a connection, if you remember, is the process of actually extracting a connection and getting a brand new connection for that client. So accepting a connection creates a new socket connection for that client, right? This is where the TCP handshake happens. And now we get 22. That's our first client, the telnet client that I opened on the new window, right? So now we get it. And then second one, what do we do in the prepare phase? Immediately, right? This is done, by the way, in the poll phase. We're going to talk about that in the next lecture. But now we do an add, and then we add the 22, which is the new connection that we received. We want to listen on data received on this guy. But then after a few seconds, we received data from this guy on 22. And then, hey, what happened? Look at that. Equal wait, we received something. What do? We just print it. Receive data. That's just write 17 and write 22. So we're writing to the connection, right? And write is a POSIX call, which like you can do it on every single thing, right? You can do it on the screen, 17, right? I want to print it to the screen. And I also want to write data to the connection, 22. But then look, we got some more data coming on from the 22. And we keep going and we keep going, we keep going. And all of a sudden now, we have, look at that. We have a client that got disconnected. We closed the connection, remember? So now what happened after we close the connection? 22 is done. What do? We do an equal delete. We remove it. Again, this is also happening in the prepare phase. So anything that equals CTL is happening in the phase. And this is where we shut down that connection. But few after that, we actually, if you remember, we keep receiving a new, was it 22 or 21? Yeah, it's 21. This is something I missed. But look, we accepted two connections, right? One is 21 and one is 22, right? And I just missed that other accept. But yeah, we got two connections. So 21 and 22. 21 is the first connection, 22 is the other one. And then you just go on, and then we delete the 22 because it's closed, and we're done. So this is just an example of what's going on behind the scene. And you can spend really hours just going through this massive log of things. And I love going through it, and I'm learning so much new things every time I do that. I'm pretty sure you're gonna appreciate that. And by the way, this number, this is the process ID, right? And but we will spend most of our time in this course looking at these. We're gonna look at what node sends, and we're gonna extract and understand so much stuff. So don't worry if you didn't understand that. We're gonna spend so much other lectures going in deep details about this stuff. So let's see you in the next one.